lesson, we're going to be learning the Pythagorean theorem. It's a theorem that's used often during geometry, and from here on out, you'll see it a whole lot. It's used to find the lengths of the sides of a special kind of triangle called a right triangle. So this is a triangle that has at least, well, not at least, but only one right angle in it, but it does have a right angle. It was developed by a Greek mathematician named Pythagoras. That's the name of it, Pythagorean theorem. For these right triangles, the longest side is called the hypotenuse. It's located opposite of the right angle. So if I were to draw a right triangle here, so it's a triangle that has a right angle that's indicated by this little square right in this one corner, so that means it's a right angle, and the hypotenuse is opposite of it, so opposite over here would be the hypotenuse. The other two sides are called the legs. So each of those are legs, but the opposite of the right angle is the hypotenuse. So the Pythagorean theorem says that in a right triangle, if A and B are the lengths of the legs, and C is the length of the hypotenuse, then we can say that A squared plus B squared is equal to C squared. So the sum of the squares of the legs is equal to the hypotenuse squared. So let's look at some examples where we use this theorem to find the lengths of the side of a triangle. So here I have a triangle that has a leg with a length of 5 and a leg of a length of 12, and N is the hypotenuse. How do I know it's the hypotenuse? Because it's opposite of the right angle. So this is hypotenuse. So when I write when I use my theorem, I'm going to say that 5 squared plus 12 squared is equal to N squared. So N has got to be alone on one side as the hypotenuse. I'm going to use PEMDAS to solve this. So I think it means I'm going to do my squaring first. So that's 25 plus 144 is equal to N squared. I'm going to add and get 169 is equal to N squared. So to solve it, recall that we need to take the square root of both sides to undo this, and I'm going to get the square root of 169 is 13, and the square root of N squared is N. So my answer is 13. B, same situation, a little bit of the same situation, but a twist in there. Notice in this one that we have a radical that's included in the length of one of the sides. And notice that that side is opposite of the right angle. So that means that this is the hypotenuse, and therefore it's going to go in place of the C. So when I set this equation up, I'm going to say that 6 squared plus x squared is equal to the hypotenuse squared, so 2 square root of 13, the entire thing squared. So PEMDAS, I'm going to square everything and get 36 plus x squared. When I square 2 square root of 13, it's going to look like 2 square root of 13 times 2 square root of 13. So front times front is going to give me a 4. Square root of 13 times square root of 13 is going to be 13. So it's going to be 4 times 13. So now I'm going to have 36 plus x squared is equal to 52. So now I will subtract my 36 from both sides and get that x squared is equal to 16. I will take the square root of both sides and come up with an x is equal to 4. My last example, same thing, but another little twist there. 7 square root of 2, is it a leg or is it a hypotenuse? I can see that it's opposite of the right angle, so this is the hypotenuse. All right, so that means that I'm going to have n squared plus n squared is equal to 7 radical 2 squared. Well, n squared plus n squared is equal to 2n squared. And then 7 radical 2 is going to be equal to 7 times 7, which is 49. Radical 2 times radical 2, which is 2. So 2n squared is equal to 98. Divide both sides by 2, and I get that n squared is equal to 49. And then take the square roots of both sides. So the square root of n squared is n. The square root of 49 is 7. All right, so let's use it in a little bit different figure. So here we have a trapezoid, and we're going to be looking for the value of k. Let's spot that there. So we need to come up with a plan for getting what k is. So you can see that it's actually part of a right triangle. So here's my right triangle here. You can see my right triangle. You can see the right angle in there, so that's in there. So I need to calculate. I have one of the sides, one of the legs is 10, but I don't have the other one. But if you notice, I have along the bottom is a length of 20, along the top is 15. So that would mean that this length right there is 15 as well, since it's a rectangle. So if that length is 15, the entire length is 20, that means that this length must be 5. All right, so now we have our triangle, we have the 2 legs, and we're going to use that to figure out what k is. So I have 5 squared plus 10 squared is equal to k squared. And again, note that the k is opposite the right angle, so it is the hypotenuse. PEMDAS, so that's 25 plus 100 is equal to k squared. 125 is equal to k squared. So when I take the square roots of both sides, I'm going to end up with k is the square root of 125, which is 25 times 5, so that's 5. Radical 5 is equal to k. Let's do one more example in this video notes. I have the diagonal of a square that's 5 square root of 6 inches long, and find the square side length. So, all right, so we've got a square. So what do we know about squares? Correct, the sides are all the same, but we don't know what the sides are, so we'll call them x. Where's my x's? I'm looking, I know that the diagonal in a square is 5 radical 6 inches long. So since it's a square, we know that this has a right angle. And so you can see the right triangle that we're going to be working with here. So 5 square root of 6 is it a leg or is it a hypotenuse? Well, it's opposite the right angle, so it's a hypotenuse. So we're going to say in this that x squared plus x squared is equal to 5 radical 6 squared. That gives me 2x squared is equal to 5 times 5 is 25. Radical 6 times radical 6 is 6. So 2x squared is equal to 150. Divide by 2. X squared is equal to 75. Then take the square root of both sides. and we get that x is equal to 25 times 3. So x is equal to 5 radical 3. So we'll say 5 radical 3, and that is inches for that. So we could put that in our calculator and find out a little closer to what we want to see rather than 5 radical 3, but we'll leave it right there for now. We'll finish this up tomorrow.